Good morning. Hi, I'm Jiun Lee, and joining me today is Mr. Saegon Kim, both representing Samsung Electronics. Earlier this morning, during VP Ho Bong-kwon's keynote speech, we saw the exciting future plans of the Tizen platform and its ongoing evolution. And now, we're going to introduce some of the features that await you in Tizen 8.0. In this session, I'll be highlighting the core features of our platform, while Mr. Kim will explore the features related to multi-device experiences. So, let's dive into this topic. These are the contents. The first topic I want to introduce is our Multi-Modal Interaction Framework. Some of you might be wondering, what exactly is multimodal interaction? Multimodal interaction is a type of human-computer interaction that utilizes multiple channels or modes in communication. Let's start by imagining a scenario many of us can relate to. Imagine you're seated on your couch watching your favorite TV show. The episode ends and your TV screen prompts you with a simple question. Do you want to continue watching the next episode? The traditional and most common way to respond to this prompt is by using a remote controller. However, in a system that supports multimodal interactions, you have more options to respond. You can speak to your TV when your hands are occupied, or use gestures like a thumbs up or the OK sign when you're unable to speak clearly. But multimodal interaction isn't just about offering multiple options. It's also about combining these modes to make your intentions crystal clear. For example, imagine saying yes while giving a thumbs up, ensuring your TV understands your intent even more clearly. And let's look at the 3 key advantages of integrating multimodal interaction into your application. First, it can be truly natural, as it resembles how we interact with our surroundings in our daily lives, like making hand gestures when talking. Second, because it feels natural, it is also intuitive. It requires minimal learning curve for users, especially for seniors or children. Lastly, it is flexible. It adapts to user preferences and accommodates varying user needs and contexts. Despite these advantages, implementing multimodal interactions in reality is not easy. Let's consider implementing the TV scenario we discussed earlier. A user's verbal yes command along with a thumbs up or OK hand gesture to translate into a positive response, minimizing the chances of unintentional recognition. One of the challenges developers face is the need to learn various sets of APIs, such as microphone and camera APIs, along with automatic speech recognition and gesture recognition engine APIs. They also need to understand various data types, their formats, and efficient handling. Synchronizing data from multiple sources with different timing and processing latency is another key consideration. It's important to note that this example represents a simplified version of multimodal interaction. If we aim to integrate more input devices or recognition solutions for improved usability, the complexity will increase dramatically. We have navigated the complexities of multimodal application development, and now let's see how our framework addresses the challenges we discussed earlier. Instead of requiring application developers to handle underlying technology, we have encapsulated core functionalities such as audio recording, transcription through ASR, video capture, and gesture recognition into nodes. These nodes represent functional units that developers can freely use to compose multimodal scenarios by connecting them with links that represent data flows and placing them on a canvas, which we call a workflow. With this approach, developers don't need to be experts in each individual technology. They can focus on generating new ideas and exploring how various combinations of these nodes can deliver an innovative interaction experience to users by creating workflows based on these nodes. Now, let's see how our framework is used. An application developer creates a workflow by placing various nodes, including functional units, and also logical units that perform operations like comparing values or checking conditions. These ensure that the workflow will recognize a multimodal event when certain conditions, as intended by the developer, are met. Once the workflow design is complete, the developer provides the workflow information to the MMI manager, the framework's system-wide controller process. The MMI manager analyzes the workflow and creates an instance of the workflow. This instance, in turn, generates instances of each node responsible for producing output data based on input data or by reading directly from input devices. When the workflow recognizes a multimodal event defined by the workflow design, it notifies the application about the event. Now, let's take a closer look at how you can create a workflow using our GUI editor. Please keep in mind that the GUI editor you see here is a prototype version, so the final look and functionality may differ upon the official release. You can drag nodes from the left panel and drop onto your workflow canvas and connect them with links. These links pass data between nodes. You can also add logic nodes to compare node outputs with specific values. For instance, in this example, we are adding two predefined strings with the names trigger phrase and trigger gesture, which the application developer can later customize to their desired values. When both conditions are met, the workflow generates an output named response. Once you have designed your workflow, you can export it as a workflow script file named prompt.mws. This script file can then be loaded by your applications. Now, let's put the exported workflow script into action. First, define a callback function for the desired event. And then, load the script file, create an instance, and set the callback function. Next, set trigger phrase and trigger gesture attributes. Finally, activate the workflow. As we have seen, implementing multimodal interaction with our framework greatly simplifies the development process. Now, let's explore some of the advanced features of our framework. First, we offer pre-built workflows for common interactions, saving you time and effort in creating your own workflows from scratch. We are actively working to provide more pre-built workflows that can be used across various applications. Second, since not every interaction scenarios can be accommodated by our standard nodes, developers can create custom nodes using our APIs. This empowers them to design specialized workflows while leveraging the capabilities of our existing nodes and framework. Third, our framework efficiently manages resources. When multiple apps request the same resources, such as video capture or gesture recognition, it detects and efficiently shares these resources. This approach minimizes system overhead and optimizes performance. Now, let's explore the benefits of our framework before concluding our first topic. Throughout this presentation, we've seen how our framework simplifies multimodal interaction development, saving time and effort. This advantage becomes even more valuable when integrating new devices or technologies. Device manufacturers can leverage our framework to not only provide comprehensive, system-wide multimodal experiences, setting them apart in the market, but also to create devices that use fewer resources for rich multimodal interaction support. In summary, these benefits empower developers and manufacturers to enhance multimodal experiences for their users. Now, it's time to continue to our second topic, and let's start with a few questions. How often do you take pictures or record videos in your daily life? Or how frequently do you find yourself viewing and sharing other people's visual content on social media platforms? In today's world, taking pictures, shooting videos, and sharing them have become commonplace activities. We do this not only to remember our daily experiences, but also to teach and share knowledge with others. It's all about using media to capture our lives and connect with each other. Can you imagine a day without using any media? As more people create content, technology improvements have made video shooting and editing accessible to everyone while enhancing their capabilities. Today, there are tons of editing tools out there that offer incredible features. And also, we can't discuss technology improvements without mentioning artificial intelligence or AI, a term you likely encounter often. AI is rapidly evolving, seamlessly integrating with editing tools. Now it can identify faces, track objects, and even create images and videos. The possibilities are expanding every day. But despite the advancements in technology we have witnessed, it is still challenging for many people to edit videos for sharing with friends and family. Imagine this scenario. Recording a video of a child enjoying a ride at an amusement park. Upon review, you notice an unknown individual in the frame. To protect their privacy on social media, it's essential to hide their face. Additionally, there are sections where the child's face isn't visible and needs to be edited out. Furthermore, the loud background noise from the amusement park obscures the child's voice, requiring noise suppression. All of these tasks demand considerable effort. So, how can you simplify this editing process? Traditional methods involve manual editing for each video, but is it feasible to invest so much effort every time? Can you find a more efficient way? Now let's dive into the core of our topic, Open Video Intelligence, or OVI for short. OVI is an open source video editing framework designed to simplify and accelerate the video editing process. It accomplishes this by connecting plugin-based video analysis and processing modules. Let's explore its structure. Users can send requirements to OVI using different APIs to express their needs. These requirements are conveyed logically using operators like AND and OR. OVI core, the key component, analyzes the video, collects analysis outcomes, performs video editing tasks as per user request, and delivers the final result to the user. While analyzing, OVI core analyzes user requirements and sets the best order for plugin operations. Each plugin analyzes the video frame one by one and operates sequentially. Core determines whether to operate the next plugin based on the analysis result of the plugin, which allows unnecessary analysis to be avoided. These previously mentioned plugin-based modules are utilized for the analysis and editing process. OVI offers 3 distinct formats for the final output: the edited video file itself, OTIO for further editing in external software, and XGS, which leverages GStreamer's editing services. In this way, OVI enables developers to create a wide range of applications. But does OVI merely simplify application development? Well, it goes beyond that. The possibilities for developing analysis and editing plugins are endless, and OVI allows anyone to develop and utilize custom plugins within the framework. Providing an environment that allows those plugins to work well is also one of the important roles of OVI. Now, let's see how OVI addresses the demands of editing an amusement park video. Within this scenario, the face recognition plugin identifies a child's face, collecting data regarding its presence or absence in various sections. Concurrently, another plugin scans for faces other than the child's, accumulating relevant analysis information. With the analysis phase concluded, OVI proceeds to the editing stage. OVI render takes charge, applying stickers based on the analysis results and effectively reducing background noise. Finally, OVI render assembles the final video by seamlessly removing sections where the child's face isn't visible and merging the remaining footage. Now, let's take a look at some sample source code that displays bounding boxes using face detection through OVI. It also automatically trims sections without detected faces. Additionally, OVI provides a convenient command line tool that accomplishes the same task without the need for extensive coding. For more details on this, please visit our GitHub repository where we provide additional examples. Okay, now, features. Application developers can utilize OVI's capabilities to create applications with a wide range of editing features thanks to multiple plugins. Plus, you have the flexibility to use various output formats that suit your needs. Also, OVI offers plugin developers a chance to seamlessly integrate into the OVI framework, ready to be utilized in various products and applications. Minimizing the time-consuming tasks like video encoding and decoding is a bonus. Add to that, OVI offers a command line tool for quick testing and debugging. Lastly, OVI supports multiple operating systems and programming languages, which will be covered in detail on the next slide. Now let's explore the future of OVI. We aim to expand our support for different operating systems. We are currently focused on Linux and Tizen, but we are preparing to support Android, iOS, Windows, and more platforms. Regarding programming languages, although we mainly use C, C++, and Python today, we plan to embrace languages like C#, Rust, and others favored by developers. OVI currently supports file input only, but we plan to add live streaming support to meet growing demands, especially with the rise in IP cameras and security systems, making OVI even more useful. And please keep in mind that OVI is an open source project. Although it's still in its early stages, you can check out the code at the URL provided. We eagerly welcome those interested, especially those passionate about plugin development. Let's collaborate, share ideas, and grow together. To wrap things up, we've now covered OVI's future roadmaps, bringing our presentation on OVI to its conclusion. Now it's my pleasure to hand the microphone over to Mr. Kim, who will guide us through the fascinating world of multi-device experiences. Mr. Kim, the stage is yours. Thank you.
Thank you, Ji-hoon. Good morning, everyone. My name is Sae-kwon Kim, and today I'm going to talk about the multi-device experience with sharing experience platform. What is a sharing experience platform? During the development of services such as care services, togetherness services, telepresence services, there are times when the involvement of multiple devices is perceived as a necessity. For example, when developing a watch together service that allow you to view content together with your friends, the ability for devices like a TV, phone, or PC to participate in the service could be highly desirable. I'll be introducing a sharing experience platform that facilitates the management of multi-device experiences, and it also supervises video calls, messaging, account management, push notification, room management, device casting, and so on. The Sharing Experience Platform SDK allow you to generate services like Connect Time that you can directly download from the Android Play Store. The SAP SDK, we have two main parts, the server and the client. The server is like a big brain behind the scenes. It takes care of things like making sure your account is safe and managing virtual rooms for video calls. It's also responsible for sending your voice and video to the right place with a relay path. Now, the client SDK is a tool that app makers use. It helps them create groups and communities inside the app and support group creation, remote camera, which is a device casting, edge computing, video calls, and etc. For video calls and data communication, the platform internally employs WebRTC technology. It allows for multi-device communication without the need for any additional plugins. The SAP SDK is using JavaScript so that it supports cross-platforms such as Tizen TV, Android phone, and iOS phone, and of course, Tizen fridges. In this presentation, we'll briefly look through at the technologies in the SAP platform, such as firstly, communication method in SAP, in which the connection between client is facilitated by hybrid network, that is both peer-to-peer network and a server forwarding method. Secondly, the remote camera functionality for the devices that does not have camera. And thirdly, on-device edge computing for security optimization. Let's see one by one. The SAP aims to establish connection through peer-to-peer networking, which helps in optimizing latency when compared to connecting through an SFU server, which stands for Selective Forwarding Unit. Peer-to-peer connection offers speed and security since they bypass the need to go through the server. Internally, the SAP efficiently handles the management of the video relay path, minimizing the utilization of server resources so that the developer minimizes the latency between the clients. While most communication in our system are secure due to the use of peer-to-peer connections, there are instances where a direct peer-to-peer connection cannot be established. In such cases, the data must go through an SFU server. We understand that the developers and customers may have concerns about the security of their data under these circumstances. To address this, we ensure robust security management in place so that the SFU server cannot eavesdrop the video or audio content that the user is sending. With the security provided by the SAP SDK, both peer-to-peer and selective forwarding unit SFU server connections are employed. While peer-to-peer connections can be generally safe, when data flow through servers, we must introduce additional safeguards. While servers have the capability to access and potentially view the content they handle, furthermore, they often find themselves targeted to various types of cyber attacks. To address these concerns and bolster the security of the data in transit, our approach is the use of media data encryption. Participants in these data exchanges share cryptographic keys among themselves. These keys act as a secret code that unlock the data, ensuring that only authorized individual can decipher the transmitted information. By encrypting data streams, even if a server were to be compromised, the intercepted data would remain never viewable to unauthorized parties. The Sharing Experience platform offers an exciting feature, device casting experience. It supports API that facilitates the discovery of nearby devices and seamless screen sharing among devices linked to the same user account. Imagine this scenario. Your TV is in a low power mode. However, if your mobile phone detects a compatible TV under the same user account nearby, you have power to elevate your video call experience. With a simple choice, you can migrate the call to the TV. What's remarkable is that the TV will automatically turn on and will join your video call within the same room. This capability not only enhances user experience, but also ensures uninterrupted and engaging communication. In cases where a camera is not available on the TV, the Sharing Experience platform seamlessly allows you to utilize the camera on your smartphone. This adaptability ensures that your video communication remains uninterrupted. It's all about making your experience smoother and more enjoyable. The sharing experience platform is designed to utilize the power of edge or on-device computing for a multitude of important reasons. First and foremost, let's talk about the security. In an age where data security is paramount, we made sure that your data remains safe. How? By avoiding the central servers when we can. When we utilize edge computing, we sidestep potential security concerns when a central server is in the mix. But that's not all. It's not just about where your data resides. It's also about how we protect it. When we utilize edge computing, we can implement lighter, more efficient security measures compared to the heavy security algorithms often needed with server-centric approaches. And there's another benefit, budget savings. By reducing the processing load on the servers, we are also helping developers keep their budget in check. It's a win-win situation, enhanced security with a budget savings. Imagine that you have a basic TV that can't handle multiple video streams at once during a group call. Let's say these streams need to be combined into one video, which usually happens on a big central computer. Here's the thing. When a central computer does this combining, it means that video can be seen on the server computer. That's not always safe. But with edge computing, we do things differently. Instead of a central computer doing all the work, we let one of the people in the group call handle it. They decode and mix the streams safely on their device without exposing it to the central server. This is power of edge computing. It keeps things secure while making sure your group call works smoothly. Thank you for listening to the new features in Tizen 8.0. Due to time limitations, I won't be able to hold the formal Q&A sessions right now, but please be aware that we have a networking session, and please visit the networking zone to ask us any further questions in the networking